In this video, we're going to see about the very common physiological basis questions that have been asked from the section nerve muscle physiology. So let's quickly see one by one. First question, what is the or why does the action potential originate in the initial segment? So what do you mean by initial segment? It is this region here is called the initial segment. And an action potential originates in the initial segment quickly because it is in this initial segment that is the highest density of voltage gated sodium channels. We know for depolarization we need the entry of sodium through voltage gated sodium channels. So this area has got a high density and thus its threshold is low for an action potential to be triggered there. That is why the action potential originates in the initial segment. Next question, why isn't there any retrograde transmission of nerve impulse? Here also the main reason is the voltage gated sodium channels. We know voltage gated sodium channels have got an activation and an inactivation gate. So in the resting state the activation gate is closed. Once the sodium channel is activated, both the gates open and there will be entry of sodium. But the problem is, as soon as the voltage gated sodium channel is activated, it goes into an inactivated state due to closure of this inactivation gate. So during this time, whatever impulse reaches the this channel, it will not be able to cause entry of sodium ions. So this period is called the absolute refractory period. So thus, as the impulse moves, once that sodium channel is activated, it will move on to an inactivated state. So that is why retrograde transmission does not occur. So it is because the absolute refractory period prevents backward propagation. The voltage gated sodium channels remain inactivated post firing and thus you have a unidirectional nerve impulse flow. Next question is, why is there faster transmission in myelinated neurons? So what do you mean by myelinated neurons? Neurons that have got myelin sheath. So we know that in areas which does not have the myelin sheath is called nodes of Ranvier, and this area has got a huge density of voltage gated sodium channels, and thus the impulse will jump from one node of Ranvier to the other. During this time, actually what happens is this positive charge or the depolarization is actually moving through the axon via electrotronic conduction, and during this time there is no leakage of charges because of this myelin sheath. So myelin sheath insulates the axon, preventing ion leakage, and by saltatory conduction the impulse just have to jump between the nodes of Ranvier, and this makes the conduction velocity very high. So that is why we have increased transmission in myelinated neurons. Next question is, why do we have Tinel sign in nerve injury? What do you mean by Tinel sign? Tinel sign is basically a clinical test where tapping over a nerve will elicit a tingling sensation. So suppose you've got a nerve injury and you tap on that nerve, then you have a tingling sensation. Now this usually indicates nerve regeneration or irritation, and so it is used clinically to assess the nerve damage or nerve growth or nerve regeneration. Okay, so that is meant by Tinel sign. Next, why does tetanus toxin cause muscle contracture? So for that we have to understand the basic neuromuscular junction, the basic mechanism of neuromuscular junction. So when you know that when a nerve action potential reaches this neuromuscular junction, that will be opening up of voltage gated sodium channels which cause fusion of the vesicles with the presynaptic membrane, which leads to release of acetylcholine into the neuromuscular cleft. Now here the problem is the tetanus toxin will disrupt the docking proteins at the synaptic terminals. See, there are proteins that help in the fusion of the vesicle with the presynaptic membrane. That is how acetylcholine is released to the synaptic cleft. So the toxin will not allow this movement to occur, and thus the neurotransmitter will not be released. Now suppose a neurotransmitter is an inhibitory one. What happens? There is continuous stimulation, and this will result in a sustained muscle contracture or spasms. That is why tetanus toxin causes muscle contracture. Botulinum toxin causes flaccid paralysis. Here it is the same thing, but here the neurotransmitter involved is acetylcholine, and you know acetylcholine is a neurotransmitter that helps in muscle contraction. So here acetylcholine is less, so muscle contraction is less, and thus it leads to muscle paralysis or weakness. Next question is, why does severe cold increase shivering? Or why does the body shiver when there is severe cold? Now this is because shivering has a ability to generate heat through muscle contractions. So body wants heat because it's severe cold. Thus it will stimulate these muscle contractions so that the heat will help to maintain body temperature. And the shivering is an involuntary process to cold exposure. So basically shivering occurs so that muscle contraction will help to generate heat that is required for the body. Next question is, why do we say relaxation skeletal muscle is active? See, we know that muscle contraction is an active process because it requires ATP. Just like that, relaxation skeletal muscle is also active because if relaxation has to occur, the calcium must be moved back into the sarcoplasmic reticulum. And for that, we have a pump which is called this Sarca pump. And this is active. So only if there is ATP, the calcium can be pumped back, and only then relaxation can occur. That is why we say the relaxation is an active process. So calcium pumps actively transport calcium back into the terminal cistern. Active transport requires ATP expenditure, and thus removal of calcium allows the muscle fibers to relax. So that is why we say relaxation in the skeletal muscle is active. Next question is, what is the physiological basis of rigor mortis? What is rigor mortis? Rigor mortis is basically the stiffening of muscles after death, and this stiffening is due to ATP depletion. The principle is same as that we have said before. See, for muscle relaxation we need ATP, but once the person dies there is no ATP production, and thus the muscles will remain in a contracted state. As because there is no ATP, so naturally the muscles will not relax. So that is why the muscles will remain in a stiffened state, and that is called rigor mortis. And this actually lasts for several hours after death. It's only after some time when the putrefaction begins that the relaxation or the muscle proteins degrade. So that is the physiological basis of rigor mortis. Next, why do we warm up before sports? Now this is because when you warm up before sports, it increases the blood flow to the muscles, it improves the muscle elasticity as well as joint mobility, and also reduces the risk of injury during exercise. So that is why we warm up before the sports, so that it reduces the injury. Next, marathon runners should run slowly in the early laps. Why should they run early? Because now this has to do with the energetics of muscle contraction. See, when you run slowly, it reduces oxygen depth. So the metabolic shift between aerobic and anaerobic fibers can occur. Okay, so when you begin at a slow pace, the body will rely more on aerobic metabolism and preserves the muscle fibers for sustained endurance. So thus it helps in conserving energy, and that is why we say marathon runners should run slowly in the early laps. Next, cardiac muscle cannot be tetanized. Why? See, this is the action potential of a cardiac muscle, and this is the action potential of a skeletal muscle. What is this yellow area here? It is the absolute refractory period. So you can see that the duration is very high for a cardiac muscle. So because of this long refractory period, you cannot summate the impulses. So whatever impulse you give during this time, it will not amount to a contraction. So because cardiac muscle has got long refractory period, it prevents summation of contractions and allow the heart to relax in between beats. So that is why cardiac muscle cannot be tetanized. Now, why must skeletal muscles maintain at optimum level? See, this is the length tension relationship. Here you can see that this is the actin as well as myosin filaments, and it is when the length is optimal that maximum tension is obtained. Why? Now this law is called the Frank-Starling's law. It explains this length tension relationship. We know that optimum length means there is optimum overlap of actin and myosin filaments, which means there will be maximum cross-link formation when the muscle is at its optimum length. That is why we say that is why the body tends to regulate the muscle length at this optimum level for efficient contraction. Okay. Now, what do we mean by denervation hypersensitivity? See, what is the physiological basis for that? See, after nerve injury, the muscles will be hyperreactive to a impulse that was normally not that reactive. Why is it so? Well, that is because there is an increase after a nerve injury. There will be increase in the number of receptors on the postsynaptic membrane. There will be an upregulation of the number of receptors on the postsynaptic membrane. There will be an increased sensitivity of the receptors to the neurotransmitters, as well as decreased reuptake of neurotransmitters. That means usually there will be some substance to decrease the amount of neurotransmitters there, but in after nerve injury, in order to make sure that an impulse is transmitted, there will be decreased reuptake of neurotransmitters. That means there will be increased amount of neurotransmitters in the cleft. So all this will cause a heightened sensitivity to neurotransmitters after denervation, and this is called denervation hypersensitivity. So three reasons: upregulation of receptors, increased sensitivity, and decreased reuptake. So we've quickly seen the important physiological basis questions that can come from neuromuscular physiology. I hope this was useful for you. Thank you.